Please join us in welcoming to the stage Mardis and Phnam Bagley.
Hello. Hello, everyone. Good morning.
Hi, everyone.
I know we lost an hour, so it's a little bit early today for some of you. But we're so happy to be here again at South by Southwest to present a very inspiring talk, hopefully. We're going to travel in space and time today. We're going to talk about design. We're going to talk about humanity. And we'd like for you to participate in dreaming with us about this beautiful future we want to build for everyone. My name is Phnam Bagley.
My name is Mardis Bagley.
And we have the same last name, not because we're brother and sister. We are husband and wife. We are based in San Francisco, and we are both designers of different kinds. I am an industrial designer, so someone who designs physical products for mass manufacturing. And I'm also an aerospace architect, so someone who designs how people live in space.
And I am started out as a graphic designer, but now primarily an industrial designer, and do a lot of things in outer space as well. And funny enough, we actually lived in Austin twice, so it's always fun to be back here and kind of come to South by Southwest and see all those local cultural things that we love and miss so much.
All right, so the subject today is going to be about designing between Earth and space. We have many, many stories we're going to share with you. We're going to be on this planet. We're going to be in other countries. We're going to be on the moon. We're going to be in deep space. And it's going to be really fun. So let's start. If you want to tag us, there are some links here you can use. There's a special surprise at the end of this talk. We're going to do a giveaway of one of the products that we are going to present. So stay tuned. So a little bit about us. So our company is called Nonfiction. And what we do is that we turn science fiction into reality for a better future. That's a real job, right? We actually created a job that really fit what we wanted to do out of life, right? Both Mardis and I have had a career designing a lot of things, phones and servers and headphones and things like that for a very long time. But it was it was not that fulfilling. And so science fiction was a great inspiration for us to really reach far in crazy ideas and technology. What we do, our special sauce, is that we don't just do design. Design by itself, if you ask us, is kind of useless. Design is only useful if you merge it with other disciplines, with business, with technology, with science, and with art. And we merge all of these disciplines to create meaningful innovation.
And as a company, we're very lucky in that we've chosen to align ourselves with things that have more impact. We've set ourselves a certain amount of goals, and 3 goals in particular. The first goal, to work with nonfiction, is we have to innovate like never before. Everything we do has to be a novel technology, so never produced, because that's how we feel that we move the ball forward and we can make true lasting change in the world around us. Number 2, you have to adhere to at least one of the United Nations Sustainable Development Goals. Now, there's 17 of them. And if you can't align with one of those great goals, then we don't want to work with you. And that's really fun to say to clients because they're kind of blown away by it, but it raises the bar. We're not dying to put things in landfills or make things just to make things. We want true lasting impact. And how do we get that true lasting impact? Number 3. And that is creating a path to execution and success. Everything we do, we have a goal in mind of creating it, to produce it, to allow it to be distributed en masse to people in need for true lasting impact.
All right, here's the big question, why space? Well, I mentioned earlier that I'm an aerospace architect, so someone who really digs deep into the problems of how it is to live in space. Because for a long time, we have designed space for people who are highly trained to go up there. But you're seeing more and more space tourists and people like you and me going up to space, and it's going to become more and more common. But we need to update the way we design our spaceships, our rockets, our space stations in order to fit our needs, because we don't have time to go through 10 years of training. But one thing that's very interesting about space is that it accelerates innovation. Number one, you've never met someone who works in space and hates it, right? Everybody is super excited about it, wants to talk to all the kids, all parents about it. It's fun, right? And it's been shown, in many examples that I'm going to share shortly, that a lot of things that we use every day actually come from space. But another point to why space that's very important is that a lot of this innovation that's been accelerated in space can be brought back to Earth to benefit each and every one of us. So I was telling you about examples. Here are a few of the things that we use every day: prosthetics, monitors for blood sugar, solar cells, water filtration system, GPS, wireless communication devices, even the lens on your camera phone. All of these things were invented in this space to benefit each of you. So now we're going to start telling the stories of the work that we do and how they relate to space and how they relate to Earth. So this is astronaut Anne McClain, and she's wearing, this leather cap that's pretty common for astronauts that go up in space. And you see the telecommunication devices on her. And they look like they were designed 40, 50 years ago, and they haven't been updated much, right? So it's a lot of very basic adjustment systems and basically booms on both sides of the mouth. What if we redefine the future of how we design things that touch the body, wearables, communication systems? What if all of these products were a natural extension of the human body? The body doesn't have any straight lines. It doesn't have any perfect radii. It doesn't have any blinking lights or buttons. So why should we design technology that looks like that? So here, introducing human headphones. It's the first on-ear headphones without a band, and it's pretty magical. We created this new way of attaching to the ear, and the whole interaction with the sound system that is attached to each ear is very natural. The geometry is natural. And it just clips in a way that, once you figure out how to do it, it feels like second nature. But in order to create a product like this, we had to align many different disciplines that sometimes don't really get along with each other. So we had to work very closely with mechanical engineers, electrical engineers, acoustic engineers, and other people in the company. And really meeting every day and aligning all of our goals together to create this superior product that has never been seen before. The interaction is also natural, not just the geometry, right? Turning up the volume, you just slide your finger on the surface outside using capacitive touch technology. If you want the next song, you just go forward. Another really cool thing about this product is that it's translates in 11 languages as you walk down the street. So this geometry was very difficult to do because if you look at ears around you, there are small ears and big ears and fat ears and weird ears. They come in all shapes and sizes. And so to create a hard geometry that fits most of these ears, we needed to do a lot of prototypes. Comes in 3D printing. So what we did is that we 3D printed and 3D modeled and modified models every day for about 6 months. And we came up with about 700 prototypes of different parts that ended up in a geometry that had never been done before. So there are plenty of patents that actually cover that right now. So now we have access to technology that is an extension of the human body. So you can wear your astronaut helmet, or you can wear big hair, and you still have access to beautiful sound.
And Phnam, I'm going to step in here and say, so we often get a lot of questions about the technology that we work with and the things that we developed. And it's important to have open conversations. We're always here. We are actively answering questions. And I encourage you to use the South by Southwest app. There's a little button on our page that says Engage, and you can post your own questions in there. And we're going to find some time at the end to hopefully answer some of those questions.
Awesome. All right, next project. Here is how people work out in space. So working on space is very important because when you live in microgravity, in isolation, in a stressful environment exposed to radiation, you tend to lose bone mass and and you experience muscle atrophy. So you have to work out about 2 hours a day, every day, on top of the super packed schedule of maintenance and work you have to do all day, every day. The astronauts stay up there an average of 6 months, so there's a lot of changes happening in the body.
All right. So what if we said you could learn new skills, new athletic skills, new behaviors 40% faster? Now, we've done this when we developed the product called the Halo Sport by Halo Neuroscience. And what it does, it applies a little bit of electricity, a very small amount of electricity to your motor cortex. And it allows you to put the brain in a similar state of flow where you can actually learn new behavior faster. So imagine if you are a high-performing athlete. You can actually, it's not about like, am I stronger, am I faster? Everybody's strong, everybody's fast. But if you can learn a new behavior, a new technique 40% faster, you can get that 1 millisecond shaved off to win that race or whatever you're competing for. This is really exciting news. Now, if you are thinking about, how do I find my motor cortex? Most people actually don't know where that is. So that's why we put it into a headphone form factor. We put the neurostimulators into the band that goes over your head. And when you put it on, it actually aligns perfectly with the motor cortex and allows you to stimulate the brain in a very gentle and ultimately powerful way to allow you to improve performance. The exciting part about this is now we can gather metrics about how the brain is your training and the amount of stimulation you need to make your experience focus on your body.
All right, after working out, let's talk about sleep. This is how you sleep in space. You attach yourself to a sleeping bag. You have your arms floating around. You don't have the comfort of gravity pushing you against your favorite mattress. There's not much privacy, and there's a phenomenon that's going on aboard the International Space Station that's pretty crazy. Oops, it's not playing. You should see it. Anyway, there's supposed to be a sunrise and sunset happening aboard the ISS. So the International Space Station rotates around the Earth every 90 minutes, which means that there are 16 sunrises and sunsets a day, every day. Yeah, imagine doing that for 6 months. So what's really hard is that it really messes up with your circadian rhythm, and a lot of astronauts actually experience a lot of sleep problems. And so when you Google, I can't sleep, what do I do? A lot of environmental solutions come to you. And basically, it tells you, oh, go buy these expensive sheets, or close all your windows and make sure there are no noise around. All of these things certainly help, but what is really going to help you more is dealing with the neurological aspect of sleep. And so that's what we're doing here with a company called STEM Science. So they are a branch that came out of UC Berkeley, which are our neighbors. And basically, some neuroscientists and psychologists there discovered that there's a way to teach your brain how to fall asleep. So the way it works is there's a very specific pattern of brain waves that happen when you're feeling a little drowsy just before sleep, about 15 minutes before, right? Your eyes are like slowly falling. And so that specific pattern can be taught to your brain by using a gentle electrical stimulation on the forehead. And basically, after you wear it for about 15 minutes, you can take the band off and then fall asleep. The magical thing is your brain knows what to do the rest of the night. And so what it does is that a good night's sleep is basically 4 steps of sleep. We're going to call them N1, N2, N3, and deep sleep. And we go through this cycle 4 or 5 times a night. A good night's sleep is uninterrupted between all of these phases. And so basically, we designed this product that, as you can see, is like inspired by nature with like wavy silhouettes of mountains and covered in silk, and it's very comfortable. And then you fall into this controlled state of sleep. And just to give you an idea of how effective this product is, one of our own employees is a woman of a certain age, and she's been experiencing insomnia most of her adult life. And she became one of the beta testers on this product. And on night 2, she was able to experience 8 hours of sleep. But not only 8 hours of sleep, she would experience 1.5 hours of REM sleep and 1.5 hours of deep sleep. That's exceptional sleep. And she's been able to keep that rhythm every night she's been using the product. Another side effect that's incredible about this product is that you can keep all of your terrible bedtime habits. You know, like scrolling on Instagram for hours or reading a very exciting book. You can still do that because neurologically, your brain is still taught how to feel drowsy and how to stay asleep all night. So I announced earlier that there was going to be a giveaway. So we're going to give away 2 Somni headbands at the end of all of this, so yay. I'm gonna give you instructions, yeah. We're gonna give you instructions at the end of this talk, so stay put. The rest is gonna be really fun too. All right, let's talk about the next project. So this is monitoring your health in space, right? So there's no privacy in space. You know, your blood samples, your urine samples, your feces samples, your body temperature, your heart rate, everything is monitored all the time, every day, the entire time you're up there. Because microgravity and isolation and all the things that space gives you is very dangerous for your body. So monitoring all of that and learning from that monitoring is very important. So it's quite a lot of work, and if something goes really wrong, right, there's no doctor there to help you out. There's no surgery, like massive surgery that can happen in microgravity. There would be blood everywhere. So we're thinking pretty hard about how to give good health care to people who are not next to doctors. So Mardis.
So imagine, whether you're in your space station or even here down on planet Earth, it's oftentimes extremely difficult to get to a doctor when you need a doctor very quickly. And oftentimes it can take months depending on the procedures. Imagine if you had a device that could operate anywhere in the world and give you information about your body through, we'll call it telemedicine. For instance, imagine, next slide, if we created a robot in the shape of a pill that you could then swallow, and then it could look inside your body, tell you a little bit about your gastrointestinal system, maybe look and find cancers or other ailments, and then give feedback. All done from a remote location. The doctor's on the other side of the world, or maybe even off-world, using something like a game controller to do that. Now, the prototype you're looking at today is not the current state. The current state is actually quite a bit smaller. It's 12 millimeters in diameter. So we've really shrunk it down quite a bit and made it something, while still big, very swallowable and digestible. And this new technology, it has a camera in it. It has a video camera in it. It has propellers like a submarine to orient it around through your stomach and your gastrointestinal system to give live feedback about your body from anywhere in the world. And the cost has been dropped drastically. So even rural communities, underserved communities can take advantage of this very, very powerful tool. And in working with ND addicts, we created a video to tell the origin story and kind of where this idea came from. And we'd like to share that with you today.
The inspiration actually began earlier in life. We went to see this movie called Inner Space. You just sort of assume when you're young and you see stuff like that it's real in some way, or that it will be real in some way. The question we ask is, could we maybe turn a couple of months of visits to the hospital into a Zoom call? Our dream of creating a pill bot is kind of beginning to become more and more real. What you see right here is kind of where we are right now. And what is it going to look like in the future? Like, do we make it smaller? Maybe it could be like the 2001 space pod with the little robot arms that come out. Pillbot is now micro-sized. It's in your brain, and we might be able to catch things like cancers like tens of years before you might otherwise catch them. So here's to the future of telemedicine.
Exciting stuff, huh?
Yeah, it's
and we're lucky in that we get to work with founders, inventors, and people changing the world, and we're very privileged and happy to be along with that on that ride.
Yeah, at this point, the CEO, who you just saw, swallowed 16 of these pills. And if you're wondering how we get rid of them, we poop it out. So. All right, next story. This is a view of the moon during the Apollo 11 mission, which happened 50 and some years. You can see the American flag on the left. No, this is not wind, it's just like a bar on the top, just to make sure that everybody can see who was in charge of this. But one thing I'd like for you to notice is the shadows on that pictures. The shadows on the moon are very dark. They're very stark. And so visibility within those shadows is going to be very, very hard. And that's just, the moon, which is right here. What happens if you go deep in space? What happens if you go on the surface of Mars? And the communication time is going to be much farther. And so one thing that's going to be important to deal with in space when you do extravehicular activity is visibility. How are we going to make sure that they see where they go, they don't trip and hurt themselves in situations that would be much more dangerous than if they did the same thing on Earth? So what we did is that we developed helped develop a technology that does the same thing on Earth, specifically for firefighters. Mardis?
So imagine you're in a firefighter, a first responder going into a burning building with zero visibility. This is a life or death situation, not only of yourself, but the people you're potentially rescuing. So we're working with Quake Tech to develop a device that fits inside of an oxygen mask of a first responder that has a camera built into it does thermal mapping, a thermal camera. It does edge detection, and it displays all this information on a AR screen that the firefighter looks through. So what you see here is something that is really outstanding. Imagine this firefighter going into zero visibility and suddenly seeing the frames of a doorway, the stairs of the steps of a staircase, or even a person that he or she would not normally see can suddenly be seen. This is a lot of technology crammed into a very small space, and it took hundreds of prototypes to get there. There is, not only the technology that you see here on the left-hand side, that's what you would normally see, but on the right-hand side, this is what the AR is showing you. Suddenly, you can see like you've never seen before. Also exciting about this is, since it's using 5G to kind of process this information, it sends it back to the captain waiting at the side of the fire truck. That data is being captured as three-dimensional data on their tablet. So suddenly they've got a whole view of what the building might look like, and then they can disseminate that to the other first responders so they too know that what the building looks like, what areas are safe, what areas are covered, what areas are not. This technology is saving 15 to 20 seconds off of every single entrance into a burning building or a disaster situation. 15 or 20 seconds is somebody's lives. That's really hugely important, and we're glad to see that it's being deployed in the Menlo Park Fire Department and a number of other areas throughout the country. As you know, or may know, maybe you don't know, when you're changing behavior in first responders, for instance, firemen, policemen, military, they're used to doing things the same way over and over again because reliability is key to their success. They have to absolutely rely on everything. And this is why we're doing rigorous testing with the Quake see-through technology to build up that comfort, to build change behaviors so they can take this technology, adopt it, and use it in real practice.
All right, now let's talk about mental health. This is Commander Scott Kelly. You probably have heard of the twin experiment up in space. So Scott Kelly has a twin brother called Mark Kelly who stayed on Earth for 1 year as Scott was in space for 1 year. And they were doing comparative studies of what's going on with them physically, emotionally, and socially. And there was a lot of difference. Mental health is a huge problem when you're isolated from the rest of humanity. Your life is essentially threatened every day of your life. You're doing quite difficult work. Your schedule is packed from morning to the evening, and you basically see the same people, for 6 months at a time. And so that takes a toll on you. And that's just being on the International Space Station, which is 250 miles away from the surface of the Earth. Imagine what happens when we stay on the moon as we settle there. What happens when we go into deep space, we reach Mars and perhaps beyond. So there are certain aspects of mental health that we need to tackle remotely in order to make that happen.
So we're working with a doctor in Silicon Valley to help people that suffer from PTSD, extreme anxiety, and even eating disorders. And what she's done is she started to develop a technique where she includes vibroacoustics, smell, breath work, aromatherapy, and infusions of ketamine to rewire the brain and how it deals with these very stressful situations. And you might ask why ketamine? It's because ketamine and some other drugs will actually rewire the brain so the brain works like a muscle. Your neurons fire over and over again, and then you develop a sort of a pattern where you automatically respond in a negative way. You automatically respond to anxiety in the same way over and over again. Under certain influences, ketamine being one, you can actually break that up a little bit. You can distract the mind, if you will, to some degree, and allow it to fire in new directions, allow it to maybe not go down that path of stress and anxiety over and over again. So we took that opportunity and said, well, what if we can do a little bit more with this? Because ketamine is a very strong drug. People are often very uncomfortable under it. If we develop a virtual reality environment and take them slowly through it, not as entertainment, but as a contemplative state, we can take them through a journey that passes through different parts of their experience in their therapy. We've figured out that in six one-hour sessions, we can go from someone who has extreme anxiety, extreme PTSD, to someone who is starting to function the way they want to function, the way they need to function, and be happier in life. So as you can see, we're showing a few stills of some of the VR experience. The idea is it's very natural because we all love nature. We see water and we're very comfortable. We're at peace around it. And as we go through it and as the ketamine kicks in, we sort of add more color to the experience and lighten the load, take the load off the people's body as they're going through the experience. And at some point, we release what we call the balloons. And it's this great release of energy, and then we bring them back down. And this is starting to create this environment where they're no longer scared. They can dream, they can create hope, or believe that they have greater hope. And we're starting to see not only are people coming out of these experiences, these therapeutic experiences, in a way that they are happier, mentally stronger, but when you put a VR headset on someone and they're really captivated, they're engaged in this virtual environment, we can effectively reduce the amount of ketamine that they need through their therapy by nearly half. That's exciting. We've done this certainly in the PTSD, working with the doctor, but also in the Stanford Children's Hospital and other environments without the drugs, but reducing the amount of stress that they need when they're going into surgical environments and things like that.
All right, there's hope for the future. So when I started, studying how we live in space about 20 years ago, there was one thing that was very stark to me, is that space to this day still looks like this, right? This is a place that's crammed with a lot of boxes on top of each other. Everything is white, blue, gray. There's not a lot of life. People don't really live like this on Earth. I mean, I hope not. And so what we really wanted to do is to make space more human. what does making a space more human mean, right? What do we integrate into this environment to support us physically and mentally? So this picture is aboard the ISS right now, and there's stuff everywhere. There's an estimated 100,000 lost objects aboard the International Space Station. That's very scary, right? And if any of these objects flies off in the wrong direction, the wrong speed towards you, it can be life-threatening. So we cannot afford to do that as we build bigger and bigger missions. So one thing we wanted to explore is color. So when you look at the moon, for example, every picture of the moon is grayscale. There's like some white, some black, some gray in between, the black sky, and then you have that blue dot in the background, which is planet Earth. So when you go there for like a day or two, that's fine. Seeing the world in grayscale, it's kind of fun. But if you stay there for months at a time, working as a miner, as an engineer, as a technician, that's going to be very hard on you, especially if you go underground. So going underground is a great solution or opportunity for people who are settling on the moon to work, because the surface of the moon is actually very dangerous. As I said earlier, there's a stark contrast between daytime and nighttime, and that really impacts visibility. It also impacts temperature variability. You also have the risk of micrometeorites and radiation at the surface. When you go into a subsurface structure like lava tubes, which are natural to the moon, you can actually protect yourself from a lot of those things and have temperature differences that are a lot more manageable for the architecture. And so we're thinking about using architecture that is subsurface for that. But when you go subsurface, again, colors. What kind of colors do we integrate into our lives? How do we work out when we are on the moon? Do we just, transfer the same, Home Depot-looking environment that I showed you earlier, or do we create an environment that feels like you're running in a field or, on grass? Same thing for the work environment and manufacturing. Instead of just having to import everything and impact them in rockets from the Earth to the moon, perhaps you can create microarchitectures like personal spaces by 3D printing materials. Part of the materials are going to come from Earth, because we don't have a choice, and some of it may come from the moon itself, so you don't have to transport all that weight off of the surface of the Earth. And for everything around you, why do we have to have these like rectilinear boxes that are white, gray, and blue? Why can't we have natural geometries, natural textures, natural colors to really, bring back that familiar feel that we have when we live on this earth? We look at a tree, we walk in nature, and really get a lot from it.
If you can't tell, we're big proponents of color, so.
Another thing that's very interesting about space is what are the opportunities for all of the industries that are around us. 50 years from now, it's going to be very common for every industry to have a foot in space. I would like to remind each and every one of you that 100 years from now, pretty much nobody believed that 100 years in the future, it would be common to fly from one country to another on an airplane. And so it's going to be the same thing with space. 100 years from now, it's going to become quite common for us to go to space, or at least go to the limits of it, above the atmosphere. And so one application that we want to look into is an orbital university. And this was a project done with the ISS US National Laboratory, as well as the World Design Organization. And the idea was to create twin labs in microgravity and on the surface of the Earth. So right now you have universities with labs that are doing fantastic work in biotech, in robotics, in physics, in different types of science. And wouldn't it be great to know what happens when all of these same experiments happen in microgravity? What is the difference between the two? One of the things that we've discovered so far is that chemotherapy in mice is more effective in microgravity than it is on the surface of the Earth. We don't know why. We need to know why. Because if we know why, maybe there's a way to accelerate care for the people on this planet. So here we invite you to really dream about an architecture of an orbital university that not only supports STEM because the space so far has been very generous to STEM, right? Everything is about engineering and math and technology, and we have forgotten about the arts. We have forgotten about social sciences. We have forgotten about the human aspect of things. So let's make sure to give space to all of these other quote-unquote softer disciplines that are going to make it possible for us to go to Mars. Next subject is food. This is pretty common type of food that you eat aboard the International Space Station. You have a lot of canned, ready-to-eat food. You can see tortillas on the back. The shrimp is very good because apparently it tastes amazing up there. But you know, it's pretty limited. And a lot of the food is also freeze-dried. So you see here a bag of dehydrated spinach that is rehydrated with recycled water. So that water has been recycled again and again, which is one of the wonderful things about the ISS, but also sounds very gross.
So about a year and a half ago or so, the Canadian Space Agency, along with NASA and the Methuselah Foundation, put out a challenge to the world. They said, how could you reimagine food for deep space travel? We'll be going back to the moon, as many of you know. We'll soon be going to Mars. That's a 3-year round trip minimum. And eating freeze-dried food, eating some of the food Phnam just showed you, it's not going to last real long because people are going to be angry. I know I have certain, sort of culinary demands, and I think we all do. We need to improve that. So we took up the challenge, our studio Nonfiction, and we said, how would we reimagine food in space? So we created a conceptual design. We call it the culinary kitchen. And we redesigned what it looks like to have food in space. Not only we're just doing freeze-dried food, but imagine if we can have aeroponics, not hydroponics, but low water usage aeroponics to grow fresh greens. The first thing astronauts ask for when they get off the long-term space travel is they ask for a salad. Believe it or not, you'd think it'd be Texas barbecue, but a salad. That crunch, that flavor, that fresh taste to the mouth. But we also realize there's an opportunity for other things like algae. If we can grow algae in space, it's highly nutritious. The water actually helps inhibit radiation from hitting the bodies because it's a natural barrier, natural insulator. So we started working with algae. We started creating in an algae bioreactor. We created a prototype and we created algae balls. So kind of like granola snacks. Algae itself, not super tasty. You mix it with peanut butter, other dehydrated powders and flavors, and they're actually really tasty and very nutritious. But then we also created a barbecue in space. Now, NASA does not like fire in space. It's kind of a thing with them. But we can have a laser in space. And we can have a laser grilling chicken, tofu, any type of meat, protein, or even grilled vegetables. And we've prototyped this in our own studio, and it works fantastically. And so what it is, it's really not just about the flavors. It's not just about what they can't have. It's about the opportunity of mixing all those together and creating options. When you go up to outer space, you fill out a list to say, I'm going to have this on this day, this on the second day, this on the third day. You know 3 years in what your next meal is going to be. I find that terrifying. I don't know what I'm going to eat tomorrow, let alone 3 years from now. And creating this opportunity, giving choice to people who aren't not just going to be trained astronauts, trained military. They're going to be people like you and I. They're traveling to outer space, really going beyond workers, probably tourists at some point. What do you want to eat in outer space? We believe that a culinary kitchen like what we've designed will allow you to have that choice.
So one of the great applications of what we designed for space is how do we translate it into Earth applications. So there's a pretty wonderful company called Alaska Life. They're creating these like beautiful vertical gardens that give access to fresh food to food deserts all over the world, at places where access to fresh food that grows outside is not accessible. And so every single system we just talked about can be done that this way, can be scaled, and can use a minimum amount of resources to be effective.
Remember, space is an extreme environment. It's very difficult. Everything out there is trying to kill you. No oxygen, low gravity or microgravity, bone density loss, all these things that we talk about. If we can figure out the problems in outer space, in theory, it should be very easy to bring it back to Earth and apply these technologies. So this is kind of why we do these things.
So one thing that's very special about this project is that I was invited to do a TED Talk about this about 6 months ago.
Yay.
And you can now watch it because it just came out a couple days ago. So if you Google my name and type TED, you should find it. But this was recorded 6 months ago. So we didn't have a prototype quite yet back then. But I really talk about how we thought about all of this and how it may change the world. All right, next project. Here you may recognize this person, Stephen Hawking. Was invited to fly on a parabolic flight and experience zero G. So imagine, being trapped in a wheelchair for decades, solving all the greatest questions of the origin of the universe, and one day having the freedom to float in the air. So you can see on his face that grin of pure joy. That can be you in space, in a couple decades. So when we think about people with disabilities, these are not the people we think about when we think about astronauts, right? Astronauts traditionally are the right stuff. People who are superhuman, have multiple PhDs, super smart, super friendly, and awesome to be around. But each and every one of us is different. We have certain things we're good at and certain things we're really not good at. And that should not prevent us from participating in the future of space. And so let's talk a little bit about design for disability.
All right. So as you can gather, we do a lot of work with the brain. We do a lot of work with neurostimulation. And this product is not too dissimilar. What this is a device. We were approached by a company called Anuvo, and they said, we figure out a way to help people with extreme traumatic incidences to the spinal cord. We're talking about severed spinal cords, people that lose the ability to walk. They lose the ability to move their limbs. And they said, well, if we figure out a way to apply patches, stimulators to the lower back, and at certain points over a period of 3 years, and we don't know why or how, but there's a certain period where the body is more able to accept this neurostimulation to the lower back, to the point when we apply it just right, they can start to wiggle their toes again. And then we've actually seen that patients can walk again. This is truly amazing stuff. Now, there's still tons of therapy to go through it and to get someone to that point. But the idea that we can actually do this is amazing. So we created a product around this that encapsulated all the technology, encapsulated the stimulation gels and things like that. But the point was, we wanted it because it often has to be carried by the patient while they're going through physical therapy. So we built a clip so they can carry it easily with them or on a wheelchair or device. But we also created it, if you noticed in the design, there's sort of a topography to the device. And the point is, you have very little feeling below your body, but you do have your hands, most likely. You can touch that. And we believe that by stimulating, just even through, very organic touch like we all do, the nerves at the tips of your fingers, that's going to get your mind thinking and your mind more ready to accept the stimulation to the point where do I feel my toes moving? Do I feel my limbs moving again? And we've seen this over and over again that it actually does help. We integrated a series of lights that pulse very, very slowly and elegantly, different colors. As the pulsing of the neurostimulation happens, ba-bum, ba-bum, ba-bum. And so as this therapy is being applied to people, they can kind of see it's being applied. They can see the lights beating, almost like the stimulation is, even though they can't feel the stimulation. We believe that this is starting to help people almost put themselves in a better space. And, you know, they can almost visualize themselves walking again. And we talk about the power of mind over matter, right? This is a real thing that we've employed in this device. And we're happy to say we did a fair amount of engineering on the device and got it to a point where it got FDA approved early device designation just this last year. So they're on that way to getting this to market. Now we know medical devices take a long time, but knowing that they've passed that first hurdle of FDA approval is absolutely outstanding, and we're looking forward to the future with the Nuvo. So another device that we did a few years ago is called the Cala Trio. And many of us know or have heard of tremors. We see it in elderly people often. It's where the hands tend to shake, sometimes the head shakes uncontrollably. It's not just older people oftentimes, it's younger people too. But you can imagine people can't drink a cup of coffee, they cannot use the telephone or the keyboard. These are things that change people's lives. They can't actually interact with the world around them. And so we designed a wearable that goes on the wrist, and it stimulates the medial and radial nerves to help calm down the tremor. Now, normally this is a very invasive procedure that goes in the brain, or it's very heavy drugs, and we don't want to take too many drugs, obviously. But imagine a non-invasive wearable that you could just pop on one day, wear it for 20 minutes a session, and to calm down your essential tremors. And you can see in this slide the difference of before and after. After a session with this device on your wrist, it actually calms down. So suddenly you can cut that apple, which would normally could be a dangerous thing, holding a knife. You can write your children, you can write your grandchildren, you can do all these things that we generally take for granted. This is no joke. I think it's 20 million people in the United States alone.
7.
How many?
7.
7 million people in the United States alone suffer from this condition. So we wanted to create it in a form factor that was familiar, almost like a athletic wearable, a fitness tracker, something that doesn't call out and say, oh, I have a disability or I have an ailment. We want to fit into their normal lifestyle. But we didn't just do it with the device itself. We integrated all this thinking into the packaging as well. So what you'll notice in the packaging here is there are no clamshell plastic parts fused together. There's no twist ties. We removed all that because we figure somebody who's receiving this shipped directly to their door, they're going to have trouble opening it. They don't want to have to wait for the caregiver. This has a zip tie. They rip it open. The instructions, the quick start guide is printed right there on the packaging. The natural sort of pressure of the packaging and the instruction for use hold everything in place so you don't need those twist ties. So the experience right from the opening of the package is very easy. And then finally, the lesser, you think that the wearable itself is the hero, but let me tell you a little bit about the dock. There's a charging dock that we designed. And what's important about this is, as I said, every part of the experience is very important, down to the packaging and even the charging dock. We've done many user studies, sat in, interviewed people, talked to them about what's working, what's not with our prototypes as we're developing the product. And we get to a gentleman who has an extreme tremor, what we call level 10 tremor. And he's just trying to put the device back into the charge dock so he can wear it the next time. And he keeps missing and missing. You can see the frustration on his face. And so we stepped away, Phnam and I and our team, we said, we got to refine this. I know it's just the charging dock. The device itself works great, but it's a whole system. We have to refine this. So we went back to the drawing table. We redesigned sort of that scallop where the wearable goes into and how it sits in there. We added magnets. So suddenly the device snaps into place confidently, and it makes a sound that it tells you that it's getting ready to charge. And it easily does it. And it's very, very difficult to get wrong. We took this back to the gentleman and we did the same thing. We showed it to him. We let him try it. First try. He did it. He nailed it. He put it into the charger. And you see this sort of face of disbelief and awe. He was like, did you change that for me? So yeah, this is what we do. This is the user studies, and we're listening. We figure you have the worst condition we've seen. If we're not solving for you, this is a medical device. We're not solving for anyone. So we designed it for that guy, and he started to tear up. And that is the coolest thing I've ever seen, is you can affect somebody's life so much that they emotionally are moved to shed a tear. I thought that was really, really cool and wanted to share it with you all. Thank you.
All right, one last project I would like to share with you. So there are more and more talks about space solar energy. So the solar energy that you have below the surface, on the surface of the Earth is not very efficient. I think at most it's like 20% efficiency with the solar cells that we have right now, commercially available. But when you go above the atmosphere, the effectiveness of the solar cells is a lot higher. I think it's 40–50%. And so there have been a concept created in the 1960s that says that if you have an array of solar panels that go around the Earth and then beam down that energy down to the surface of the Earth, we can actually make energy accessible for a very low cost to everyone on this planet. And so the US Air Force and a handful of startups are actually working to develop something like this. Not only the panels themselves are going to be on satellites, but also the technology necessary to beam it down to Earth. So beaming it down, we use, it would be through radio frequency or microwave. So right now there's some tests being done in some deserts in California to make sure that we're not losing too much of that energy. So it's very promising. And so think about all these people who live in very remote places in the world. Like we're working with rural Africa, specifically Tanzania and Nigeria. These people don't have access to electricity, or if they do, it's really scattered. It's not really reliable. On top of that, certain regions of Tanzania have a lot of clouds. So even if you have solar panels, you kind of rely on sunny days to have access to electricity. But electricity is not just, having enough power for your phone so you can scroll on your Facebook. It's really access to education. It's access to healthcare. It's access to communication and information that helps you advance in life and grow up, knowing what's going on in the world. And so we designed this battery, super low cost battery for that market that can be rented in those hubs. And so the hubs are scattered all over rural regions of Tanzania and Nigeria, and they're attended by 100% young women who otherwise would be perhaps married off at age 18 or working in a field. And so we designed this battery to have some sort of like local flavor. The enclosure is made out of very resistant plastic, but also we're using local fabrics, kitenge fabric specifically, to create a handle and a cover for the ports of the battery. These are very foolproof. Right, you just plug it in and you plug it into your TV, to your radio, to whatever device that you want. And here I wanted to show you an example of this gentleman, Fabiano. He is a barber in rural Tanzania. And as a barber, he's buzzing, his clients' heads. He's, playing some jams as he's working all day to make sure that, clients come back and have a good time. And he could not have a business without reliable electricity. So thanks to this swappable, rentable, very low-cost battery that costs up to like $3, $4 a month, and you can swap them as often as possible, he can have a business. He can build his own life. He can build independence. And I mentioned earlier, these women, these jazz stars is how they're called, are building a sense of independence, of monetary independence as well. And I'm happy to announce that about a year ago, the first jazz star who made enough money to actually attend college. So this is just the beginning of hundreds and thousands and tens of thousands of people whose lives is going to change because of this simple access to solar energy.
I absolutely love that story. I think that's really cool. End to end, that story is just beautiful, and I still like hearing it.
Yeah. So yeah, to conclude this talk, we talked a lot about life in space and life on Earth and how they're connected to each other. We create technology on Earth that can serve space. We create technology in space that can be brought back to Earth and serve each of us. But really, let's not focus on, first world, US, Europe, China, and countries like this. There are so many places in the world where people have dreams of working in space. I'm talking to people in Morocco, in Belize, in New Zealand, in Bangladesh, who want to have a future in space. So think of all the little girls and little boys in the world. How do we create an infrastructure that is going to help them get to their dreams so they can build the future with us? So if you like what you saw today, Mardis and I actually have a YouTube channel that you can see. I don't know if you can do the QR code because there's the closed caption on top of it, but you can always come to us. So yeah, or you can go on future.design. So we love to tell stories about design, and we like to share a lot of things for free. So both Mardis and I were college professors back in the day, and we find that it's very important to share the way we work as professionals so more people, not only designers, business people, scientists, technologists, engineers, understand how we think so we work together towards that beautiful future. And so, as I mentioned earlier, there's a giveaway. We're gonna make it kind of simple. Just go after 2 social media platforms. We're going to ask you to go on either LinkedIn or Twitter or both, and then do a post about the talk you just saw. All we ask you to do is hashtag nonfiction design in one word and Somni. This is how you spell it. Just these 2 hashtags, and then whoever gets the biggest number of likes, of shares, and of reposts is going to win a Somni. One Somni is dedicated to LinkedIn post, and one Somni is going to be dedicated to the best Twitter. So may the best one win. And that's it for now.
Don't forget to check out Phnam's TED Talk.
All right.
It was just released, so Phnam Bagley at TED, I guess.
Yeah.
Yeah.
Yeah, that's it.
Thank you all for coming out today and listening to us.